to learn about volume and surface area of a sphere. The formula are given to you. There's no way to prove it. You learn where the formula come from in year 12. But now we just need to know the formula. Okay, in year 12 you'll learn where this formula come from. Okay, so we just assume this formula. So for the volume is 4 over 3 pi r cubed, and for the surface area is 4 pi r squared. Okay, so this one you have to remember. So we do the first question. Once you know the formula, these questions are very easy to do. So to find the surface area, you just go 4 pi r squared. So you go 4 pi times the radius, which is 7 centimeters, and then use your calculator. So you have a calculator in front of you. Please try that on your calculator. Press 4 times pi times 7 squared. Okay, so you will get this number here, which is the surface area, 615 point, round to 2 decimal place, 75 square centimeters, because it is area. Once you do that, find the volume as well. Volume is the same thing. You go 4 over 3 pi r cubed. So remember, volume has a cube, surface area has a square. Okay, so you go 4 over 3 times pi times the cube of the radius, which is 7 cubed. Again, you use your calculator. So you press the button. So you go 4 pi times 7 cubed. Oh, 7 cubed. 7 cubed. Right, like that. And you just write divide by 3. So you get 1,436, round to 2 decimal places, 0.76 cubic centimeters. Alright, done. Question. Alright, it's very straightforward, this part. You just apply the formula. Okay, and then we can do the reverse. If we gave you the volume, how do we find the radius? Well, you just use the formula again. V equal to 4 pi r cubed over 3. Write 10 equal to 4 pi r cubed, because they give you the volume. And you have to solve for the radius. And to solve for the radius, you first multiply both sides by 3. And that cancels. So you end up getting 30 equal to 4 pi r cubed. And then to get the radius, you get r cubed, you divide by 4 pi. Right? And then to get the r, you have to cube root it on your calculator. So on your calculator, you press cube root. There's a cube root button. Press shift square root. Remember, you shift square root to get the root. Cube root, and then apply fraction 30 over 4 pi. You just type what you see. Good. You get that. Okay, so you correct to 2 decimal places, and you will get 1.34. So write 1.34. And that's in length, just m. Okay, that's a length. Okay, so now we know how to find the volume, surface area, or given the volume, finding the radius. Okay, so it's pretty easy. Alright, once we do that, we can then move on to the next example, a composite shape. Hopefully you have all finished. Composite shape. This composite shape here, that looks like an ice cream cone. So we're going to find the volume of that and then the surface area. Let's start with the volume. So the volume, you can see, it consists of half a sphere and then plus a cone. Okay? So half a sphere, you just go half times 4 over 3 pi r cubed, and the radius is, oh, we don't have radius. I just realized. Okay, so how do we get the radius? You just subtract these two, you get 2, right? And this is actually your radius, right? Right, that's the radius. So the radius is 2. So you go 2 cubed. And how about the cone? Well, the cone is the same thing. 1/3 pi r cubed and the pi r squared. So unfortunately, the radius actually is given as well too. So you go, they share the same radius, so it will be 2 squared pi r squared times the height, which is 5. Okay, so that's the height of the cone. And then we have to, oh, how do I get, rid of, very annoying. Alright, good, thanks. Alright, oh, I ruined it. Okay, good, I can't do it. Alright, so press the button on a calculator, please. So practice this on your calculator. So you go half 0.5 times 4 over 3 multiplied by pi times by 2 cubed. That's the volume of the hemisphere plus the volume of the cone, 1/3 times by pi r squared 2 squared times by the height of the cone equal. You get that, okay? So you get this one, 37.70 correct to 1 decimal places, 2 decimal places. Now notice that I left a gap there because I want to be able to show you how to find the exact volume. Exact. So to get the exact, what you need to do is just do this on a calculator. So we go half times 4 divided by 3 times 8. That gives you, shift that, 16 over 3 pi plus, and the other one you get is 1 divided by 3 times 4 times 5. That gives you 20 over 3 pi. And if you add them together, you get 36 pi over 3, which becomes 12 pi. So the exact answer is 12 pi, if the question asks you for the exact, okay? Alright, any question? Alright, pretty straightforward. Okay, let's do the surface area. The surface area is, now remember, for this surface area, you do not include this circle because it's covered, you can't see it. So anything you can touch is the surface area. Anything is inside, you can't touch. Interior, then you don't include in the surface area. So it includes the curved bit, which is pi RL, plus the one on the top, which is half of 4 pi r squared, half of the hemisphere. Now we need to do something extra. In this question, we don't have the slant height. So what we have to do is calculate the slant height, which is this length here, L. So you have to use Pythagoras. So the triangle is 5 and 2, that's L. And using Pythagoras, you go L squared equal to 2 squared plus 5 squared, which is equal to 4 plus 25, root 29. Okay? And then you can just use the formula. Remember, r is 2, so you go pi times 2 times root 29. That's the curved surface area of the cone, plus half times 4 times pi times 2 squared. This time you just do it on a calculator. So you press shift pi times 2 times root 29. That's the curved bit. Plus half times by 4 times by root pi, shift pi times 4. Yes, that's the exact, no, that's the approximate surface area. Correct 2 decimal place. So it will be 97 square centimeters because this is an area, surface area. Okay, any questions? These questions are not, yep, I will just leave it on for a few seconds. Now we're not done yet because I still want to go through the revision and then we're done for this topic. So we'll do a revision of all the shapes. All done? Alright. Alright, finish. Yeah, if you know everything, you have to do the textbook question, yeah.
I have to leave early today.
Yeah. Yep, no worries. Remind me when the time comes.
Yeah.
Okay.
If I could borrow a calculator.
Yep. Alright, there you go. Yeah. Alright, okay, can we move on? Let's go to the next page. 2 more pages to go through, then you can do the work. Thank you. Okay, let's start. Okay, continue. Okay, good. Limits of accuracy is half of the smallest unit. The smallest unit. That gives you the limits of accuracy. And then unit conversion. These are all pretty easy. You just times by 1,000, times by 100. So you should remember this because we did it so many times. Write it down. And then you go backwards, you divide. Go backwards, you divide. Go backwards, you divide. I think I have one extra 0 there. Like that. And of course I could cheat a little bit. Let me see how that works. So, oops. So like this, Control C, Control V. It's exactly the same thing. Oh, they overlap. So it's exactly the same thing, except that you're going to add a square. Square, square, right? For the area, you just have to square it. Get the idea? So it's pretty easy. And same thing for volumes. I think I'm running out of space, so I have to write it again. So like this. So that's 10 divide by 100, divide by 1,000. This is times by 1,000, times by 100, times by 10. And these are cube for volumes. Okay? So it's not hard to remember. Alright, any question? And you need to know the capacity stuff as well, the megaliters, kiloliters, liters, and milliliters. And this is very easy because they are all 1,000. You just have to remember the order. Okay, mega, kilo, liter, and then milliliters. All done. Question? Yes? Why what? Scroll up. Yep. Smallest unit. Okay, good. So now we're going to do capacity. It's the conversion between volume and capacity. 1 cubic centimeters is 1 milliliters. 1 liters is 1,000 milliliters, which makes 1 liter is 1,000 cubic centimeters. Conversion between capacity and volume. And then you also have cubic meters, which is, remember, it's 100 by 100 by 100 cubic centimeters, which become 1 million. Okay. And 1 cubic meter, which is 1 okay, let's write it like this. 1 cubic meter is 1 cubic centimeters, but there's a 1,000 cubic centimeters in a liter, which makes it 1,000 liters, which is just 1 kiloliter. Right, remember these facts. Okay, good. Any questions? These are conversions. We're now going to review all the area of all the plane shapes. These formulas need to be known in the exam. You need to memorize them. So square will be S, so it will be S square, side square. Rectangle is length times by breadth, LB. And the area of a triangle is base times height, the perpendicular height, half BH. Oops. Half BH. Okay, good. And then parallelogram is just base times height, BH. And the area of the rhombus, I should write their name. This is a parallelogram. Rhombus is half times the 2 diagonals. Same for the kite, which is half XY. Okay, question. All good? Alright, and the next one is trapezium, which which is half HA plus B, and the area of the circle is pi r squared, and then the sector is theta over 360 pi r squared. Alright, these are all the plane shape you need to know, which can be applied to surface area or volume, depending on what the type of question you get. Alright, question, good. I've got one more page. So we looked at the plane shape. There's also 3D shapes we have to look at, both in terms of its volume and the surface area. So there's a summary there. Let's go through the formula. For a prism, you just find the area of all the faces, Alright, sum of areas of all the faces. So most of these are rectangles plus the cross section, like that. Usually the cross sections front and back are always the same. Yep. Sum of area of all faces. Let's write it clearer. Sum of the area of all faces. Okay, done. How about volume? You just go V equal to A times H, A being this cross-sectional area, times by the height. Okay? Okay, how about pyramid? You learned that recently. So for pyramid, you have a area of the base, which can be a square or rectangle, plus the 4 triangles, which can be the same or different area, 4 triangles. Right, that's the surface area. And volume we learned from last lesson, the perpendicular height times the area of the base. So you go 1/3 A times H is the volume. Okay, done. Cylinder. Surface area is pi r squared, 2 pi r squared, because there's 2 circles. Radius times by the plus the 2 pi r h, which is the curved surface area. Curve. Surface. Okay. And the volume is just pi r squared h. Yep. Yeah. Yeah. Okay, good, done. Let's look at the cone. Let's review the cone. How about the cone? Cone is area of the base, pi r squared, plus the curved bit, which is pi r l, L being the slant height. Okay, slant height. That's the surface. So let's write down the heading. Surface area. This is volume. Right, for the volume it's easy as well. V is 1/3 pi r squared times by the perpendicular height. Alright, okay, and then we've also got have the sphere we just did today. 4 pi r squared is the volume of the sphere, of the surface area, followed by the volume, which is 1/3, 4/3 pi r cubed. 4/3 pi r cubed, like that. And then finally, there's some perimeter we forgot to discuss, which is pi 2 pi r is the circumference, or pi d. And the perimeter of the sector involves theta over 360 times by 2 pi r. That just gives you the arc length. Okay, that's just the arc length. Okay, arc. You need to plus the 2 radius to get the perimeter. Alright, any question? So this is the summary of all the things we've done, and also there's Pythagoras, which you know very well. That's the Pythagoras. Alright, one more thing, just let me speak, sit down. There's also, now for surface area of a sphere, for half a sphere, you got to be careful. If you go half a sphere, you not only have to go 2 pi r square, you also have to add the area of the circle at the bottom, pi r square, right? Because once you cut this sphere into half, you have to include this area. Okay, that's for the hemisphere. Now, depending on whether the sphere is, hemisphere is open or not, if it's open, you don't include the pi r square. If it's closed, you have to include the pi r square. All right, any question? Okay, yep. Which become 3 pi r square. Done. Okay. All right. Before I finish,